Excuse me. Hello, everyone, and welcome to my video for equation of a circle. Circles is my favorite unit to teach. It's my favorite unit to teach because a lot of reasons. The whole unit, it's just circles, and it's a geometry unit. And I've just taught this unit so many times, going all the way back to teaching geometry. It's pretty much exactly the same unit. So I'll start with equation of a circle. So the basic setup looks like this. And H and K is the center. So you see that H and that K in there. But also these minuses play a real big deal. So for the first time on graphing day, as we graph the equation of a circle, these H's and K's, the center, it's always opposite. Just like we're used to, like our X number has always been opposite, or our left to right shift has always been opposite. Well, now the same thing that's happening to X is happening to Y. So for the first time, our up and down number will also be opposite. But anyways, long story short, if that didn't make sense to you, basically the center of this one is positive 7 and negative 8. That's the location of the center. But meanwhile, though, the radius is not 36. The radius is the square root of 36. So you're always going to take this. This spot is always r squared, as you see up here. So, of course, the radius is a nice perfect 6 on this one. And I could graph that real easy. I'd go to 7, negative 8, and put a dot for my center. And then I'd count like to the right 6, or left 6, or up 6, or down 6. Moving on to the next one, where is my center at? Well, I know that my center is going to be at 3. And this is basically a y plus nothing over here. So the y location is 0. And again, this is the radius squared, so I got to unsquare it basically to find out what the radius is. The radius is 5. So it's not always going to be a perfect square root over there, as you'll see on my third one. So what's the center and the radius? Hopefully maybe you can pause the video and think about it for a second. Well, hopefully you said that the center is at negative 4 and positive 6. Meanwhile, the radius is the square root of 30. And again, 30 is not a perfect square, so I'd rather just leave it as square root of 30, which is exact. Of course, it'd be maybe 5.5 or so, give or take, for the radius. So you can also take a look in Desmos if you type these in, which this is one of the ones we did. Again, the center on this one will be positive 7 and negative 8. So you go right 7 and down 8, and there's the center. And again, we know that the radius is going to be the square root of this. With square root of 25 is 5, and note my center is 5. On Delta Math, you're literally going to take examples, very similar. I know I'm going to go left 8 and up 4 for my center. So take your center and drag it left 8, up 4. So put your center down first, and then remember, this is not the radius, this is the radius squared. So you got to unsquare it. The radius is 2, so I'm going to stretch it so that the radius is 2 blocks right there, and I'm going to submit it. Oops, no, I didn't want to hit new problem. So I accidentally hit new problem. Anyways, on this one, I'm going to go left 4 and up 1. Always opposite. So again, negative 4, positive 1 is where my center is. Again, radius is the square root of this. So the radius is going to be 5 units. 2, 3, 4, 5. Note that you can count 5 up or 5 to the left or 5 down to verify that. And another section, you're going to type out what the equation is. So it looks like the center is at about negative 1, positive 2, or positive 3. What I would do is I would count out the radius to make sure I'm in the center. So from this coordinate, if I go up Looks like I'm going up 7 from here. And it looks like I'm going down 7 from here as well. So I like the radius at 7. The center is right where my cursor is at -1, 2. But remember, I'm going to put x plus 1, always opposite. Don't forget your squares. Plus sign in the middle, always a plus sign in the middle. And of course, I went up 2, so I'm going to put y and -2. Again, don't forget the square. Most of the time when I'm correcting kids, they'll forget the squares or they'll forget the plus sign in the middle. And again, remember my radius was 7, but then at the end I always got to put my radius squared, which is 49. But one other thing about circle equation. If somebody took the x minus squared and multiplied it out, which would be x minus 7 2 times, and they FOILed that together, or box method, and then they do the same on the y side because y plus 8 is to the second power. If somebody combined the like terms, the 49 and the 64, and subtracted over to the 25, they'd end up with this version, and this is called general form. General form. So one thing I need to be able to do is show you how to turn it back from general form into the regular form that we're used to. So one thing that you can do though is just type general form in on Desmos, and once you do that, you'll see your circle and you can tell like, hey, my center is at 7, -8. So I know the equation with the center being at 7, -8. I know the equation is going to be x minus 7 squared plus y plus 8 squared. And then the radius is 1, 2, 3, 4. Ooh, it doesn't look like a perfect 4. 1, 2, 3, 4. So I don't think it was a perfect number radius there, but as far as normally doing this, it would be a perfect number. Don't forget, whatever your radius is, squared at the end. But aside from using Desmos, and if you want to be a Desmos person, that's great. That's basically all you need to know for this video. But of course, I need to show how to do it without Desmos. So if you made it this far, and you just are satisfied with what you got, then great. Thank you for watching. But meanwhile, just to throw in, you're going to need some factoring skills, which are very important in the rationals unit. So first thing, you want to organize your x's, and I'm going to put my y's in a different color. Y squared minus 8y. And I'm going to move that -11 to the other side as a positive 11 when it moves over. Basically adding 11 to both sides. So I need to come up with a number here and in this spot. And that number that I choose, it's going to have to factor well with the green part, and basically the number in green is going to have to factor well with the green. It's not as if I'm kind of making it sound a little bit tougher than it is. So basically we're missing numbers that will factor here in green. So all I have to do is something called complete the square. If you learn this in Math 2, good for you. All I do is I take the little first degree term and I take half of it and then I square it. So again, I take half of 6, which is 3, and then I square it, which is 9. And then I'll be able to factor with that 9, and it's actually real easy. But if I just randomly add a 9 on the left, I have to add a 9 on the right. When I do to one side, I still have to do to the other. I'm not as color-coded as I would have liked to be. So remember, what am I going to put in here? What did I just do on this side to get the 9? Think about that. Well, hopefully you understood that I got to take half of this number and square it. That's, again, the first degree number, the first power. So I'll take half of the -8, which is -4, and then I square it, which is positive 16. There's never going to be a negative number in these blocks, because by the time you square a negative number, it just makes it back to positive. If I add 16 on the left, I have to add 16 on the right. So at this point, guess what? I know that my number at the end is 36, which helps me get my radius. All I need is the numbers for the center. Well, to factor these, you know that 9 breaks down into 3 times 3, and that's great because 3 plus 3 makes 6. So in other words, this factors down to x plus 3 and x plus 3, which is x plus 3 to the second power, which is beautiful because remember, this is part of my center, but it's always opposite. So remember, I know that my center is going to be at -3 something, and I know that my radius is going to be the square root of that 36. So my radius is going to be 6. So think about this last part. What am I going to do over here? How am I going to factor this? What's my center going to be? What's the other part of my center going to be? Well, 16 could be 4 times 4, but it could also be -4 times -4. Well, guess what? We need them to add up to -8. So it's going to be y minus 4 and y minus 4. Oops. Which is y minus 4 to the second power, which means my center is at -3, 4. And as I graphed it earlier, indeed, my center is at -3, 4. And you can count out the radius, which should be 6. So again, if you don't like that, if you're not a great factor at this point, that's okay. I still need to work on that, at least in the fall of 24. I need to work on it with my students. But most of you, again, would most likely just put this in decimals and identify, like I showed you here, what the center is and what the radius is. So anyways, make sure you knock out the delta that goes with this. Shouldn't be too difficult. Let me know if you need anything. Thank you so much for watching.